Good morning, students. Today we shall discuss about the representation of linear motion, basically graphical representation of linear motion. Okay, so what type of graph we shall draw here? First of all, we shall draw here displacement time graph. Displacement time. Secondly, we draw velocity time. Velocity time. And the third one is the acceleration time. Acceleration time. And now we are talking about one-dimensional motion. So all the motions are in a straight line. As it is not changing the direction, so of course the displacement and the distance will be same, right? It is not changing any direction. So that is why all of them are the if are they a scalar or vector quantity, that doesn't matter because they are not changing direction. So displacement time and distance time will be same. Similarly, velocity time or speed time will be the same. And acceleration, there is no such term in scalar quantity. Okay, so let's draw some graph. But before drawing graph, let me tell you something. Suppose you want to draw a graph like this. This is along x-axis and this is y-axis. Okay, that's mean there must be exist some relation between x and y, right? There must exist some relation between x and y. Of relation, let's say the graph is like this: y equal to 3x plus 2. Okay, so another relation is like this: y equal to 5x. Let's say another relation is y equal to 3x square plus something. Okay, or I can say y equal to root over x, so something like that. Okay, so if you just look very carefully to this equation, so the first two equation, the power of y is 1 and the power of x is also 1. So power of y is 1, power of x is 1. So this type of relations are called the linear relations. This type of relations are called the linear relations. And here y, if y and x have different power, likewise linear relation, this is also a linear relation. If y square equal to 3x square, then this is also linear relation because both of them have same power, right? But here in this equation and in this equation, x and y doesn't have same power. Y have power 1 and x has power 2. Similarly, here y has power 1, x has power root, means half, right? So these two equations are non-linear equation. So non-linear equation. This is also a linear equation. Okay, so we can say that in case of a linear equation, the line will be the plot will be a straight line like this or like this or like this, means whatever the lines are, that will be a straight line. But in case of a non-linear graph, the line will not be a straight line. That's when it can be a line like this or line like this or something like this, but it will not be a straight line. Okay, so in our entire chapter we shall keep one thing in mind, that whether the power are same on both sides, then the graph will be a straight line. Somehow that will be a straight line. And if the power are not same, then that will not be a straight line. Okay, so let's talk about the distance time graph. Okay, in case of distance time graph, I am plotting something like this. Suppose distance or displacement are plotted along this direction. I am plotting it with x, and time is plotted along this direction, that's mean along x-axis. Okay, so this is x-axis and this is y-axis. So first of all, before plotting, one thing we have to keep in your mind, that what is the equation. As I have told you, equations can be like this. So what is the equations, that we have to keep in mind. So in case of a displacement time graph, first try to remember all the equations. Okay, though we have not done the equations yet, but we can consider the equation here. Okay, like from the previous classes we know that distance, if we take distance, that is equal to d or x here, that is equal to velocity into time. We know this, distance equal to velocity into time, right? And here the distance x, that is power 1, and the time is also power 1. So there must be the linear relation. of course the plot will be like this. Okay, I'm talking about this. So its power is 1, its power is 1, so this plot will be like this. Now let's draw a slope of this. Slope means, we know slope means tan theta. Slope means tan theta, that's mean theta, if this angle is theta, then tan theta of this angle will be taken as slope. Trigonometry you will learn in this class. Okay, and you have to remember, if this is a triangle, let's say this is PQ and R, then tan theta must be equal to perpendicular by the base. Okay, that's mean height by base, that's mean PQ by QR or RQ. Now look at this, along PQ what we are getting? Displacement. So let's say delta x, this is displacement, and along x what we are getting? That is delta t. So delta x by delta t, so basically this is x by t, that's in distance by time, that is velocity. Okay, what that means? The slope of our distance time or the displacement time graph gives us the velocity. Is it okay? Gives us the velocity. Okay, likewise the velocity can be like this, or the plot can be like this. Let's say displacement is along this direction and time is along this direction, so the plot can be like this. Okay, because it is not can't say always that the velocity or the time and the distance always be of power 1. We can't sure that always. Okay, the relation can be like some different manner, like this can be the relation x equal to half at squared, something like this. Okay, we shall learn it maybe in our next class, x equal to half of at square or something like that. So here the power of displacement is 1 and the power of time is 2. Okay, so the graph is a non-linear graph, so it must be a arc line like this, and this line in this case will be like this. Okay, again here you may plot a slope here, and also the slope in this graph gives the velocity at this point P. Slope means nothing but tan theta you have to take. So tan theta, that is equal to delta x by delta t, that is x by t, like this, and again that is velocity. So slope of displacement time graph at any point gives the velocity of the particle at that point. I am repeating, slope of any displacement time graph at any point give the velocity of the particle at that point. Is it clear? Okay, so let's talk about velocity time graph in this case. What I'm talking about? Velocity time graph in this case. So how we can represent it? Okay, just look at this. So I shall plot a velocity and time graph. Velocity and time graph. Okay, so suppose a particle is moving with a constant velocity. That's mean, let's say this is velocity, that's mean this is 10 kilometer per hour, this is 20 kilometer per hour, this is 30 kilometer per hour, like this, and this is 1 minute, 2 minute, 3 minute, 4 minute, like this. Okay, so when I am observing a particle, it is moving with, let's say, 20 kilometer per hour in first minute. Okay, and when at second minute I am also seeing that it is moving at the same speed, in third minute also with same speed, in fourth minute also same speed. So if the velocity is constant, we get a graph like this, that's mean a straight line. Okay, which is parallel to our x-axis or the time axis. But if the velocity increases, then how the graph will change? Okay, I am drawing another one. Let's say this is velocity and this is time, and I am plotting here, this is 10 kilometer per hour, this is 20 kilometer per hour, this is 30 kilometer per hour, this is 40 kilometer per hour, like this, and this is time 1 2 3 4 5 in minute. time in minute. Okay, let's say a particle at the start of time was at rest. After 1 minute I am observing the speed is 10 kilometer after 1 minute. After 2 minutes, let's say the speed is 20 kilometer. After 3 minutes, let's say the speed is 30 kilometer, or like this. And after 4 minutes, the speed is, let's say, 40 kilometer, or like this. So I am getting a point trajectory like this. So if I join the points, I shall get a graph. But what is the difference between these two graphs? You may say that this is parallel to x-axis and this is not parallel to x-axis, neither parallel to y-axis or the velocity axis. So what is the actual difference, or what that means? That means the velocity here is not changing with time. That's mean this is a constant velocity, and here the velocity is changing with time. That's mean velocity is increasing. Velocity is increasing, right? As a velocity is increasing means this is a accelerated motion. This is a accelerated motion, because we know in case of acceleration velocity always increases. Okay, now just try to draw some slope in this graph. Try to draw some slope in this graph. Okay, I am taking these 2 points, let's say, and I am drawing a slope. I am using a different thing. I am drawing a slope here. So this is the theta, and I must have to take tan theta for calculating the slope. And we know from trigonometry that tan theta equal to height by base, and here the height means along the velocity axis, right? Height means along the velocity axis, that's mean delta v, and here the base means along time axis, delta t. So tan theta equal to height by base, that's mean delta v by t, that's mean change in velocity by time. So what is the rate of change of velocity, right? Rate of change of velocity, what that mean? The rate of change of velocity means acceleration A. Okay, so I am again giving another statement. The slope of velocity time graph of a particle gives the value of acceleration at that point. Is it clear? The slope of velocity time graph at any point of a particle gives the acceleration of the particle at that point. Is it okay? Okay, so next, so this is velocity time graph, this is displacement time graph, and this is velocity time graph. Next, last thing, the acceleration time graph. So first let me tell you one thing. All the graphs in your book or in your syllabus, that is of constant acceleration, that is of constant acceleration. So if we put the acceleration along this direction and time along this direction, this will give you the acceleration time graph. That's mean constant acceleration. Okay, now let's talk about another consequence. If we draw a velocity time graph like this, let's say this is a velocity time graph. It can be a velocity time graph. It can be a velocity time graph. I'm asking you, let's say this is 10, this is 20, this is 30 or something like this. Let's say this is 30. This is 30, and this is 1 second, 2 second, 3 second, 4 second, like this. 1, 2, 3, 4, like this. Okay, I'm asking you, what is the displacement covered by the particle after 3 seconds, let's say. Okay, what is the displacement covered by the particle after 3 seconds? So what you have to do, you have to draw a straight line parallel to y-axis. Okay, parallel to y-axis. Now we know displacement that is equal to velocity into time. So velocity into time, right? Velocity into time means something like length into breadth, means area of this trapezium. Okay, that's mean let's think in a easier manner. Let's say a particle is moving with velocity, this is 10, this is 20, this is 1 second, 2 second, 3 second, 4 second, time and velocity. A particle is moving with a constant speed 20 kilometer per second or 20 meter per second. This is meter per second. this is 1 second, 2 second, 3 second, 4 second. I am asking you what will be the distance covered after 3 seconds. So just draw a perpendicular along the 3 second axis. What I have told you, to find the displacement, that is equal to velocity into time. So what is the velocity here? 20. And what is the time here? 3 second. That's mean 20 into 3. 20 into 3, that is the answer. But just look very carefully, this 20 is the height or the length if you take, and 3 is the breadth, or vice versa you can think. So this is length into breadth. That's mean the area of this rectangle gives us the value of displacement. So displacement, that is equal to 20 into 3, that is 60 meter. This is a consequence. Okay, so this is the end of the unit. Lot of examples are in book. I shall also give a scanned page of this book as PDF. Okay, just practice them. Thank you.